Good evening, my beautiful people. I go by the name Sotadeology. In this particular live session, we're going to dissect the proof of Riemann hypothesis. This is Sotadeology lecture 29, and I title it to be the proof of Riemann hypothesis. So we're going to be dissecting the non-trivial zeros on the critical stream. That is what we're going to actually dissect in this particular video. There is a genuine solution to this Riemann hypothesis. And so we're going to actually, dissect it for us to be able to understand how this particular problem is being solved. This problem has been in existence for over 160 years, and so it's a big problem that, if solved, can actually provide solution to so many other problems in mathematics, in physics, and in some other fields. So now basically we can get to see the what is called the zeta function here, or zeta function, whatever it is that is called, whatever it is that it is called, you understand. So basically it's going to be quite informative. It's going to be so enjoyable. You're going to like it. Now, what I use in solving this particular problem is known as formula of everything. The formula of everything is actually derived to unified quantum mechanics, to classical mechanics. And so in the process of unifying quantum mechanics having solved that, then I got to realize that the non-trivial zeros that we have on that critical, should I say critical line or strip, those zeros, they are just encoded primes that, when you they are encoded primes that when you actually unravel the harmonic oscillation of the zeros, then it can actually fit the jagged what is it called, jagged prime counter function. You understand? So the function was actually developed by Gauss, you understand, and the chart is zigzag, kind of like jagged pattern, you understand. And basically, by the time Riemann introduced imaginary number to actually constitute complex function, he was able to get the trivial zeros and non-trivial zeros. So the non-trivial zero, they are the coded or encoded primes that we need to actually unravel its mystery in this particular video. Sit back, relax to enjoy what I have for you in this particular video. Okay, so now we have read the title, but before you can get to really appreciate or to understand this solution, or to appreciate the solution, I need to briefly talk about formula of everything. If you really want to know how this formula is derived, you can actually go to when you watch my videos on YouTube, you can get to see the link to the published copies on description section of my video. And when you get linked to that, you can get my published research, and there you can see the derivation of formula of everything. This formula of everything is so powerful that it feeds back on itself. So it's a formula that, when applied, we can actually use it to track decaying mechanism from quantum level to classical level, from classical level to quantum level. Now, the way it works, the way the formula works is so uh, mind-provoking, to the extent that it then lead to this discovery of how it's able to solve the Riemann hypothesis. Okay, now let's just go through the formula as we have it. This is the zeta function, and then you see that in parentheses we have s, and this is just the topmost formula that we have, is just the summary of everything, which is telling us that when you sum right from 1 to infinity, such that you have 1 all over the number, and then being squared by s. You understand? So to actually unpack that, we have what we have below, which is then written in its infinitive form as we're supposed to have it. And so we have 1 all over 1 raised to power s, plus 1 all over 2 raised to power s. Then it continues like that infinitely. So now, first of all, we just want to know that if we have this series as we have it, is it a kind of converging series? Or, yes, as we have this series, like, can this summation actually converge or not? Because we know that when we have harmonic series, even though it's contracting, just as this one too is contracting, it is not converging. It is actually diverging. You understand? So we don't want to know, but this issue of prime problem started with Gauss, just like I said. He had to painstakingly walk through the prime distribution right from 1 to about 3 million, and then he was able to get the chart that I talked about, which is jagged chart. You understand? Kind of zigzag pattern. You understand? And not zigzag as that, jagged pattern rather. Let me put it that way. So now, having that, as at that time he was actually working on a logarithm function as well, and he realized that the chart of that logarithm is similar to that prime chart pattern. So now, when you have that chart, the prime distribution chart, when you have it being so elongated in millions as Gauss did, then you realize that the jagged pattern of the chart would then be smoothened. And so later on, Euler worked on that, on this. He actually developed the zeta function. Euler solved Basel problem that is solved. So through that, he was able to realize that the series, this zeta series, is when you have the s to be 2, then it will converge to pi square over 6. Now, getting to realize that it converges, then we can actually work further on the problem. And so now you can see what we have here when you actually input 2 for s, such that we have 1 over 1 raised to power 2 plus 1 over 2 raised to power 2 continuously like that infinitely. Then it will actually converge to pi square over 6, like I said the other time. Therefore, zeta function is converging towards, pi squared over 6, unlike harmonic series that diverge. You understand? So we can only have this converging virtue when the value of s is actually greater than 1. So now we briefly look at harmonic series, and so we have that to be 1 over x, and so we can just have it 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5, like that. And then this series, as we have it, will not converge by its nature. It will actually diverge. So getting to realize that the zeta function can actually converge is something so profound. And so now let's see how all this can actually be proved further as we progress into the solution of Riemann hypothesis. Now, Riemann introduced imaginary numbers to make it a complex function. And so we then have, it to be like this. So what Riemann did was, if we could have, 1 all over 1 raised to power 2, then 1 all over 2 raised to power 2, why can't we have it to be, 1 over 2 raised to power 2 plus I? You understand? So to be a complex function, and so then, we can possibly just have 2 plus 3i, and if that is the input that we have, then we can have it to be 1 over 1 raised to power 2 plus 3i. But basically, just for you to see the introduction of the I, then I just put I right there, and then it continues to infinity. So if the scalar of imaginary number is added as a coefficient of I, the complex valid function becomes an analytical continuation function. So analytical continuation function, then in that case we can, then the entitle of the prime encoded instantiation can just be treated as half of the continued part into either higher dimension or to, yes, let me rather say higher dimension. So definitely with that we can get to see that the prime instantiation, like the encoded primes that we're going to have in that critical strip or the critical line, we just have as half of the continuous part, which when combined with that will make it a whole. So it's a big issue, because when Riemann, now explored the whole field of the whole complex field, then he realized that it got to a point where the whole elevation got, dropped down to 0. So we have vertically lined up non-trivial zeros, which we have on critical strip, and then we have some zeros that get converged for every even numbers, which is every negative even number at the other side. So we can have the sense of that by looking at this diagram as we have it. So now we have the sense of that by having this. So now you can see that what Riemann did was to, introduce imaginary number to have higher dimension. So to that one dimension of number, we then have another dimension to make it 2D, which is two dimension. By having two dimension, we have, the y-axis to represent the imaginary axis and the x-axis to represent the real axis. So now, for the real axis, we have, from the center, we have 1, 2, 3, 4, 5. Then we have the negative side, which is, negative 1, 2, 3, 4, 5. So now, I want you to look at the vertical dashed line that we have. That is the critical, that is the non-trivial trivial zeros. We have non-trivial zeros on those dashed, because the zeros are prime encoded. So now we have those zeros being lined up like that, but then we have them on or at 0.5 or 1.5, or rather, let me say half, half of 1. So 0.5 or half of 1. We have it right there. Now, what we want to solve today is to see, to get zeros that would be lined up vertically like this, and decode them to confirm if they are prime numbers, and see if they can actually by confirming it to be prime number, then we have actually made it to match the Gauss chart pattern, which is jagged prime counter chart or prime counter function. Okay, so now then another thing that we need to even pay attention to are the I don't know how to put it. It's a big problem because it's at the bottom of what reality is, and is that the vertically lined up non-trivial zeros on critical strip are encoded primes of half instantiated pointer to the O. Now, where is the O and what is the O? So the way this problem is being solved is that basically, let's look at the solved cases by formula of everything. The non-trivial zeros on critical strip have harmonic oscillations that conform with the prime jagged counting function patterns of Gauss. So now we have seen the connection from that encoded zeros that are being vertically lined up on that critical line. We have seen the connection. The connection is that when you implement the harmonic oscillation of all the zeros, when you implement the harmonic oscillation of all the zeros on that critical line, then it will match up with that jagged counting function pattern of Gauss. And by having it to be like that, we have seen that those zeros, they are encoded, they are prime encoded. So the zeros at the vertical line here, the dashed vertical line, we know that they are prime encoded zeros. Well, computer worked on this problem. Computer was able to get about 10 trillion zeros on this critical line. None of the zeros none of the zero none of the zero was actually found outside the vertical line. You understand? So for us to have up to 10 trillion zeros to be on that 0.5 spot, then it means that Riemann hypothesis or the zeta function is, I mean, it has to be genuine. It has to be genuine in that sense. So now we're going to actually generate more than 10 trillion in this solution. We want to generate more than 10 trillion zeros. You understand? And then see the connection of these 10 trillion non-trivial zeros. See the connection of the zeros to prime, and then get to see if that is somehow related to any reality at the central point, which is this 0 point. So once we are able to do that, then we have, solved the mystery problem. Okay, so well, this problem, we know it has been around for over 160 years. Claim Millennium Institute, I don't know if I got it right, they have actually decided to give, $1 million to whosoever solve the problem. Okay, the problem is solved today in this video. Okay, now let's see. We have seen what the issue is, we have seen what the problem is, we have seen what we want to solve, and so now let's proceed. Now, formula of everything, FOE, formula of everything is d to the m equal to capital UM plus 4m. This formula is so powerful that it feeds back on its own. It feeds back on itself. So if you want to know how this formula is derived, you can check out my research publication, where I will briefly share the research publication with you after solving the Riemann hypothesis. So now let's go into it. Now, the way formula of everything works is this. Formula of everything, when you, in the place of the two m's, you can actually substitute the value of quantum mass worth that you know, be it electron or anything. You can specify the mass worth of electron in the place of the two m's. And once you do that, this is what you're going to get. Now, let's see how formula of everything is applied. Application of formula of everything. So now we want to use the mass of electron. Now, first phase result. We are moving from quantum level to classical level. So now the formula, the capital U represents 2.5 times 10 raised to power 39. So that is the only mystery in the formula, capital U. So what we have here is, the speed of the universe. And so now we have that right there. In parentheses, we have the mass worth of electron, which is 9.109 times 10 raised to power minus 31 kilogram. We close that parenthesis plus, then we have this 4 outside the parenthesis, then we put the value of electron right there. So now, once you execute this, what this will give you will be the value that we have, right down here, that is being underlined. This value, we have it to be 2,277,250,000 kilogram. That is the mass worth, the classical mass worth. That is the classical mass worth of that electron's mass. So now you can see that we have this value. We have this value without having any kind of suspended zero between the. So it's as if there is no space from quantum level to the classical level. So the reason it is like that is for the fact that at quantum level we have quantum entanglement. So information is transmitted instantly. And so we could have this classical mass worth as though there is no space between the quantum level and the classical level. Then let's see, but right now we're going to see how it is possible and feasible for us to then have space. So to have space, we have to move from classical to quantum. So now, from this time, we have gotten the classical mass. We started with quantum mass, with electrons mass, and then we are able to get the classical counterpart of that quantum worth. And that is 2,277,250,000 kilograms. Now, let's dissect from classical to quantum. So now if we use the formula, but this time we're going to use the mass worth, the classical mass worth that we have gotten. We want to use that classical mass worth and then see if we can actually reconfirm the quantum mass worth. You understand? So now, by the time we have this 2.5 times 10 raised to power 39, in parentheses we have 2,277,250,000 kilograms. And so plus 4, then we open parentheses, then we have 2,277,250,000 kilograms. By the time we implement that or we solve that, then the answer that we're going to get will be 5.7 times 10 raised to power 48. 5.7 times 10 raised to power 48. Now this value is so huge, so you can see that having 10 raised to power 48, we have couples of zeros. So definitely we're going to have zeros that can actually serve as that can actually extend interval from classical realm down to quantum realm as such. You understand? So now, how can we then make sense out of these results that we have? The only way we can make sense out of these results. But now, up to this level, what we have done, if we're to use the chart right here, we have moved from this diagonal line, from the central point, central point to the left. So I call that point Big Bang point. Sorry, I didn't label it. And then the point to the right, that is black hole. So when you hear me say Big Bang, black hole, Big Bang, I'm referring to the point at the left side. So Big Bang, black hole will be the point at the right side. So now we have this diagonal trajectory in time. Now, there is something about relativity that we must know before we go ahead with this explanation. There is no way you can just have a point, any point in space, without that point being relativistically, connected or related to another point. Because the point that you have you will not be able to identify, let alone to label the point. So no point can actually stand on its own without having any relationship with any other point. So now we realize that the only way you can get to label or to identify any point in space is for that point to have another point that is inversely related to. In that case, you can say one is initial point while the other is later point, just as we might want to call it. So now, by the virtue of that relativity, we can label those points relative to each other. And another thing about relativity is that once you have the 2 points like that, then anytime one point is moving towards the other, they will both do so. They will both move toward each other. So no point can actually do, no point can actually do anything independently of the other. So basically, what I'm trying to say is that if the Big Bang point should move towards the black hole point, then the black hole point too will be moving towards the Big Bang point. So same thing is applicable if the Big Bang point is actually moving away from the black hole too will be moving away from the big bang point. So the moving towards and moving away of the two will actually be at equal speed. So that is one thing you need to know about relativity. So now that we have this as our solution, then we need to expand this in standard form. And to expand in standard form, then we have it to be approximately 5. I think it's about 5 million something, but that is why you could see that I have 5,7 right here. I'm just like trying to shorten it so that it will fit into the space that I have. So then we have couples of zeros. Then at the 32nd position, we now have the base value of electron. We have it being suspended at that 32nd to the value of 5,7 that we have right here. So we now have 9,109 being suspended, and then we have other 3 zeros at the back. Now this suspension that we have here is what we have up here. Now we have this convergence. You can see this red convergence on this red convergence here. That is the suspension. So here I'm like trying to expand the answer and then try to indicate the suspension just for us to have idea of that suspension. But the actual suspension is in form of mass worth. But then the mass worth is not a real mass worth as such, because I call it arbitrary mass worth. So the mass worth, we have it right there. Now we have this diagonal trajectory in time. We must as well have reaction of that in energy. Now don't forget that this blue curvature represents time wave, while the red curvature represents energy wave. It represents energy wave. Okay, so for us to have that in energy, to have reaction of that time action in energy, we then have this another diagonal line. So don't forget that the diagonal line, they are made up of relativity. So now there is going to be this central point that will be generated between the arbitrary convergence and then the Big Bang convergence. The Big Bang convergence. You understand? So basically, for any shape to be instantiated in space, we must have this convergence Rather we should have these convergences all around the edges of the shape before the shape can actually be in that stable condition for it to be manifested or to be instantiated. So now that we have this, now we need to close the gap, the baseline of this equilateral triangle, of the initial equilateral triangle. How are we going to get it? So we can only get the baseline by manually annihilating only the suspended zeros. By just annihilating only the suspended zeros, we have epitomized what is known as free fall, which is the classical gravity. So this classical gravity will be spontaneous, but in our case, we just have to manually annihilate it. So how do we manually annihilate it? So let's see how to manually annihilate it. So manual annihilation of only suspended zeros is classical gravity free fall into quantum gravity tiny resistance as non-trivial zeros on critical strip. So now, the moment that we annihilate the suspended zeros, because we are only annihilating the suspended zeros, there will be no force that will be exerted on that trajectory. So there will be no force at all. So we can call that free fall, because right in the free fall of classical gravity, we get to know that if you have a feather and you have a billiard ball, even though the feather is so tiny, if you have both of them in the vacuum where you cannot have the influence or the effect of air or anything on the feather or on the billiard ball, then you see that both of them will actually touch the ground at the same time. So mass is irrelevant in gravity. So the worth of the mass will be cancelled for both of them, and then both of them will actually, descend at the same speed. That is gravity for you. Well, why is it that the mass worth, because if the mass worth is accounted for or is considered, if the mass worth of the two objects are considered, then of course the billiard ball will actually touch the ground before the feather. You understand? Before the feather. So basically we can see what gravity is doing. So from there we can get to know that gravity is a field. Now I call this baseline, which is the vertical trajectory, I call it static and undulating field. The reason I call it static and undulating field is that for us to have it vertical as we have it, it means that it is instant. Then if it is instant, then we shouldn't have this elongation that will bridge right from the classical arbitrary suspension down to the quantum arbitrary suspension. So we still have this influence of energy, because for you to know, for your information, time has two identities. Now, where we have this diagonal trajectory of time to diagonal trajectory of energy, we have time being relativistically connected to energy. And so the kind of relationship that we have there has defined time to be continuous while energy is discrete. So time is continuous when in relativistic scaling with energy. Then energy is discrete when in relativistic scaling with time. That is one identity. The other identity is time is instant by default, while energy is infinite by default. And that is why we could have this struggle between time and energy. And that is why we could have the fabric of space to be dynamic, because time would want to contract, energy would want to expand, to explore all the available space. And so that is why we have this battle between time and energy. And so now the vertical trajectory is the default trajectory of time, and that is instant. The horizontal trajectory at the center, that is the default trajectory of energy, and that is infinite. Now, you can get to know it is infinite by the virtue of the inflationary suspension that we have at Big Bang, and the neutron star suspension that we have at black hole. The suspension is highly essential, and then you can see that we even have another suspension right from where we have the quantum arbitrary suspension down to the edge of energy curvature. That is another suspension. Right there we have compacted equilateral triangle, and because the equilateral triangle is compacted, the constancy of light speed will be maintained. Don't forget that the diagonal trajectory in the energy space is the constant speed of light, while the diagonal trajectory in that time space is constancy of gravity. So there is a way gravity is so adjusted to balance up the speed of light. So this is so done in a way that it ensures symmetric nature. You understand? It ensures symmetric nature. But now the thing is, even the equilateral triangle, if you have been following me, if you are so conversant with me, you know that I have these Sotadeology triangles where I have the pyramid formation of arithmetic summation, from one, then we have the summation layer by layer. One is the topmost layer, 1 plus 2 is another layer, 1 plus 2 plus 3 is another layer. I have that layer by layers, and from that we could see that we have constancy of 1 at one side, probably left side, and then we have variations at right side. So this is telling us that even right inside the symmetric nature of equilateral triangle, even though the equilateral triangle is supposed to be symmetric, then we know that it is also asymmetric. So what do I mean by that? We have this equilateral triangle, but then we get to see that the trajectory of time is actually supporting the trajectory of energy to manufacture mass worth. And that is why right inside the equilateral triangle of the time part, we can see, I want you to look at where we have this blue dark convergence. That is the real mass worth. We have this to be real mass worth, which is the classical mass worth. And that mass worth is being suspended around the point of intersection, or rather, let me say, is being suspended at the intersecting point of time and energy, which is supposed not to be. What that is actually pointing to is relativity of simultaneity, and that is what this problem is majorly all about. So now the point where this vertical trajectory is able to break this quantum arbitrary suspension for us to have spontaneous symmetry breaking, we could see that we have compacted the equilateral triangle, which I call quantum nucleus. So by the virtue of having the equilateral triangle to be compacted as what we have, then we have constantly accelerated momentum, which will then generate standing wave. So by the virtue of constantly accelerated momentum, we're going to have a kind of resistance to that free fall, and that will result to mass accumulation. The mass accumulation is arbitrary because the mass accumulation is actually towards the curved region of the energy, but then we have the value of electron, the value of electron to be 9.109 times 10 raised to power minus 31, which is bigger than the value of the suspension of this quantum arbitrary, and that is this 5.7 times 10 raised to power minus 32. So this value is bigger. In that case, it is expected that we have electron in the compacted equilateral triangle. Now, if you put this value, the curvature of energy, the value of curvature of energy, if you put it inside the formula of everything, in the place of these two m's, then instead for you to get the instantiation of electron, you only get accumulation of the arbitrary mass worth towards the curved region of energy. That is what you get. With that, we get to know that electron is yet instantiated. Now, the moment that mass accumulation is so enormous in that tiny region, then it will result to generation of standing wave, which we connect to higher dimension. That standing wave will get connected to the electron of the higher dimension, which will be instantly converted to positron in order to allow for the electron of the substrate dimension to be instantiated. And once we have that, we have what is known as quantum entanglement. Now, quantum entanglement is a transition from substrate dimension to higher dimension. Having it to be like this has cemented the fact that light speed can still be the speed limit of the cosmos. You understand? Because it is not to say light speed is the speed limit of the cosmos as such, because it is the speed limit per dimension is the speed of light. But the interconnecting speed between dimension is the instant speed of time. Now, what we have right here, the vertical trajectory represents the instant speed, the default instant speed of time. And because time is instant, there is no room for mass worth. There is no room for instantiation of mass worth. And that is why we could have free fall as classical gravity and yet have constantly accelerated momentum as quantum gravity. So now, with that, quantum gravity is so tiny, and so it will be relevant at classical level. You understand? So that is why we could not even sense quantum gravity at classical level at all. It is so tiny relative to classical mechanics. But then you now understand that we have this tiny resistance, and so the quantum gravity is the inverse of free fall. So basically we can get to say that gravity is associated with constant acceleration as such. But then now we know all this. Now I have used this to explain what consciousness is, what objective, because consciousness has two phases: objective conscious experience and then subjective conscious experience. So I may not go into that. If you want to know more about that, I have another video on my channel that you can watch. I have even answered 3 hard questions of consciousness. So now with that, we have gotten the system. So by just annihilating suspended zeros, it will not exert any force, and so it could be classified as free fall. And so now with this, we can get to see that we have these zeros on the critical strip. But how can we confirm if those zeros, the vertical zeros, the suspended zeros, because when you annihilate, just as we're going to annihilate it here, this is how we annihilate. Let me show us. I've been talking about annihilate, and I think I just have to show you guys. This is how we annihilate. So we take the zeros, all the zeros up to the 32nd position. We call it 10 raised to power 32. And then we take this value, the value of electron, the base value of electron, which is 9,109. We place it over 10 raised to power 32. And that is this. So now, by the time we'll expand this fraction such that we have 9.109 times 1 over 10 raised to power minus 32. So we expand it like this. And so we know that what this will give us will be what we have right here, which is 9.109 times 10 raised to power minus 32 kilogram. This, you can see that by having this, we have moved from, you can see that we have moved from classical to quantum realm, Now, what this is telling us is that this value is smaller to the value of the original electron's mass that we used earlier. And so what that is telling us is that the trajectory is being shifted forward. So the trajectory is no longer maintaining this the central vertical trajectory. So it is being shifted forward to this critical strip. But then how can we confirm that? So we know that the mass worth of electron is being decayed to the value that we have right now, which is 9.109 times 10 raised to power minus 32. So how can we now confirm this? Now, what I want you to know is this. We need to confirm that all the 32 zeros, the vertical 32. Now, because we only annihilate suspended zeros, the trajectory will be vertical because there will be no exertion of energy, and so it's going to be vertical, just like I said. So we now want to prove that all these zeros, they are the non-trivial zeros. That's what we want to prove now. But before we prove that, I need you to know that these trivial zeros, just like I said the other time, that the momentum of light speed, which is this diagonal trajectory, is to support mass accumulation at time trajectory. So now there is a point where the momentum is being cut to make it discrete, because it will not, the cutting that we have usually goes through 0 points. I call zero, you understand? So it usually goes through. So now the point where we have that break in momentum, that is the point where we have symmetric, where the momentum of light is symmetric with the momentum of, where the constancy of light is symmetric with the constancy of gravity. That point is where we often have discontinuity. The moment it travels through zero, it will cut it so as not to allow for mass accumulation. It is that energy, the energy of light speed, serves as thrust energy for mass accumulation. So now yes, for mass accumulation in time trajectory. So now we can see, by the time you get my research publication, I have two research publications. The first one, the time theory of the universe. The second one, seeing the anatomy of quantum gravity through formula of everything. Those two research publications, by the time you get them, you can get to, you get more information about all these things. I will put link to my research publication in this description section of this video, and there you can see the derivation of formula of everything and how formula of everything is applied. So now we can see that 0 point at which the momentum of light speed is being discontinuous in order to support mass accumulation at classical level. That is the reason we could have these trivial zeros. Why? Because for the zero is generated based on the symmetric nature of gravitational constancy to light speed constancy, and so it will be equal at that end. That transition will serve as even numbers. Now the what is it called, the sensation of infinity as we have it is related to odd number. When you cannot say you have all natural numbers up to the maximum, the moment you have 2n plus 1, it will continue. So odd number will continually give us more number to have infinity. So odd number, the virtue of having suspension, which is the phenomenon of odd number, that is the infinity that we have. And so if you now say you want to have a definite number, the only way you can have that is to have a proper subset of the infinity, which you can just get by having 2n minus 1. Now when you have 2n minus 1 to serve as the proper subset of that infinity generated by the odd number, which is 2n plus 1, you will then realize that what you have defined by definition is also odd number. So now what that will generate is that it will generate odd number that starts from 1, while the 2n plus 1 will generate odd number that starts from 3. Now we have these two odd numbers, which the 2n minus 1 is a proper subset of 2n plus 1, and that's supposed to give us definite number. Of course it will when in relationship with the 2n plus 1, because it's until when we have this inverse relationship of 2n minus 1 to 2n plus 1 that we can actually identify 2n minus 1 as a definite number. But then by definition that one also is infinity. So now basically by that you can get to see that all these vertical non-trivial zeros, they are prime encoded numbers that They are prime encoded numbers that serve as a pointer to real entity. So there will be arbitrary convergence. There will be arbitrary convergence relative to the real entity. In this case, the real entity is electron. So the prime encoded convergence in form of these vertical lined up non-trivial zeros, they will serve as arbitrary pointer, which is the half. They will serve as half pointer to the real electron. That is what they are. So now, by what I said the other time, by that virtue, then we get to know that Big Bang convergence is different from the black hole. Big Bang singularity convergence is different from the black hole singularity convergence. Why must this be like that? Don't forget that this horizontal trajectory is the default infinite trajectory of energy. Energy must be continuous, and for energy to continuously exercise momentum, of course, there must be this imbalance, because symmetric nature will cause a brief instancy. So whenever we say we have even number, we know that at that point of having the even number, we must have this discontinuous momentum, brief discontinuous momentum. And so that brief discontinuous momentum is needed at complex level, and that is why we could have this quantum entanglement. And since positron and electron, they are equal, they are of same mass, same energy, same everything except for sign. You understand? So since they are equal, the moment they get entangled, we're going to have this slight break in momentum. And that slight break in momentum, that is what we actually get rid of the expanding field of the cosmological space, such that we can have the contracting field of the black hole. So the break in momentum is highly needed for this initial equilateral triangle to be inversely converted. So now we must move from expansion to contraction. That is why we have that. But now from singularity to singularity, the momentum must continue. And that is why the convergence of Big Bang singularity must be different from the convergence of the black hole singularity. And so we can see that in the nature of the infinity, as we have 2n minus 1 as infinity, even though it is definite entity when in relativity with 2n plus 1. And then we have 2n plus 1 to be infinity, which is a kind of transcendental infinity. So we have a kind of infinity that is internally inclined, and then we have another kind of infinity that is externally inclined. So now that is the difference. So the momentum is guaranteed, but then there will be a brief break in momentum at this center, at this point of intersection. And that is why the point of reality for both Big Bang singularity and the black hole singularity is the event horizon. That is the point of reality. So the convergence of instancy is at the center for both singularities. Okay, so that being said, now we need to prove. How can we prove? How can we prove that all these zeros All the vertical zeros, they are non-trivial zeros. And what connection do they have with prime numbers? So now let's solve that to solve Riemann hypothesis. Okay, second phase result. So now, to prove that the shift of manual annihilation from 9.109 times 10 raised to power minus 31 kilogram to 9.109 times 10 raised to power minus 32 kilogram is 1.5 or 0.5 on the critical strip, we take the digital root of all the suspended zeros. So now what do we do? Suspended zeros, we have it in form of 10 raised to power 32. So definitely the totality of all the sum of the zeros will be 32. Now this 32 that we have is far more than the 10 trillion that the computer generated. I mean that the computer generated, and all of them were found on that critical strip. So now we have these 32 zeros, non-trivial zeros to work with. So now to get the digital root, we the 32 is more than the normal digit, single digit that we should have. So we say 3 plus 2. 3 plus 2 will give us 5, and 5 is a prime number. 5 is a prime number. How can we get to know that? Yes, by having it to be prime, we know that all those zeros are being encoded as prime. So now, if we should, implement the harmonic oscillation of all those zeros, they will actually match up with the jagged prime counting function of Gauss. We have solved that. Now, how can we get to know that all those zeros, they are actually being shifted to the point of 0.5, to the face of 1.5 or 0.5? So to do that, we can then say that if those zeros will be the half of if those will be half, those 32 zeros will be half, then we should have double of the 32. For us to have double of 32, we can just say 32 plus 32. You understand? Or we say 32 times 2, we have 64. Now, having this 64, if we now try to get the digital root of this 64, which is 6 plus 4, will give us 10. Having that 10 alone shows that 10 is the multiple of 5. 10 is even. You understand? But then we now see that we can't even have 10 too, because we are trying to get the digital root. So now if we should now say 1 plus 0, we have it to be 1. Now what this is telling us is that if we should be, now I want you to look at this diagram. If we should stand on the 5, the 5 is really at the center. If we should stand on the 5, if we look to the left, we look to where the 1 is, we can see that from that 1 to the 5 is half, and then from that 5 to the 10 is also half. Now, right from 1 to the 5, we are going to get 2 as prime number, get 3 as prime number. The 5 that we stand on is a prime, and then we get 7 as prime. So we have 4 primes from 1 to 10. 4 primes. So now, if we're to look at this, we can see the asymmetric nature being embedded right inside what we have, because we only have one prime number to the right, but we have 2 prime numbers to the left. That is the asymmetric nature, which must be maintained on the x-axis of real numbers for it to continuously exercise momentum. Okay, so with that, we have proved that non-trivial zeros are prime encoded at half or 0.5 or 1.5. Yes, at 1.5. At half of one. Rather, I don't know how to say this to make you understand that the half I'm talking about is the half of one. So now I have it to be half or 0.5 critical strip. So it's at that critical strip as a prime pointer to the real entity. So what is this telling us? What is this telling us? What this is telling us is this. It is very simple. By the time we get to know the by the time we get to know the position of non-trivial zeros, we can then get the real electron by just having double of that value. So by having the double of the value of those non-trivial zero, which is 64, that 64 will actually take us to the position of electron. So the moment we get so that is why I said, don't forget, that is why I said the vertical lined up non-trivial zeros on critical strip are encoded primes of half instantiated pointer to the O. That's why I said it. The moment you have the prime encoded non-trivial zeros, you already have access to the position of electron at quantum level. So just have double of all the non-trivial zeros, and by the time you implement the harmonic oscillation of the 64 non-trivial zeros, then it will match up with the pattern formation of electron. So that is how we have moved from probabilistic nature of quantum mechanics to deterministic nature of unified quantum classical mechanics. It's a unified quantum classical mechanics. So like if you look at quantum entanglement, it's a unified wave, and so through quantum entanglement we have unified dimensions. So two dimension at that quantum entanglement will cause the two dimension to be connected to higher dimension, then it will give us unified identity of 3D, even though the 2D is still embedded right inside the 3D. So that is the whole reality of the universe. So now we can get to know where the position of electron is. So basically what this is telling us is that electron cannot be instantiated until it is connected to the positron of the higher dimension. So positron of the higher dimension is not the exact positron of the electron, because the positron of the electron will actually be up here at the classical arbitrary, at where we have this compacted equilateral triangle. The real positron of the substrate dimension of electron will be instantiated right there. So having the positron of higher dimension can move toward, because we're going to have that flipping mechanism to allow the positron to be locked onto the electron of the substrate, for the two dimensions to be locked and be unified as one. And then anything can happen. The positron can actually move towards the electron without colliding with the electron, but it will then energize momentum towards the core singularity of black hole. That is what that is all about. So now, that being said, we now get the full reality of the universe. formula of everything has not only unified quantum mechanics to classical mechanics, it has made us to understand that the trajectory of reality moves from classical level through quantum mechanics to the to complex level. And by having that, we have unified identity. And at the point where we now have that unified identity of dimension and unified identity of particles, you understand, at that point that we have that, we have what is known as objective conscious experience. Because before you can have objective conscious experience, you must move at the speed of time. Now, this vertical trajectory, like I said, it is the default trajectory of time, which is instant. And by having it elongated, then it means that it is static and undulating. It is not void of momentum, but the momentum is not a kind of momentum that can actually translate from one point to another. So it's not a kind of momentum from one place to another. It's a static momentum in form of undulating. So this central point, which is also known as event horizon or the present phase of time peregrination, is more or less like the heartbeat of the universe. So we have it beating as heart at one spot, and that is it. That's why I call it static and undulating field, and it is the field of reality. So now the moment that positron is injected into the substrate dimension, such that we have energized momentum towards the core singularity of the black hole, then the classical mass worth, which is this blue convergence that we have here, will actually be relocated to the point of this intersection of time to energy. And that is when we can then have subjective conscious experience. Now, subjective conscious experience is needed for that experience, the conscious experience, to be personal. So now, the objective conscious experience is so tiny, and it is the signal that the subjective conscious experience will work on. So basically, we have solved the Riemann hypothesis because we have seen that the prime encoded non-trivial zeros, they are half instantiated pointer to the real O entity. In this case, it is electron. So they are pointer to electron, and through them we can get to know the position of electron, and then we get to see that by getting to know electron, or by getting to track the position of electron, we then have to move back to the point to this zero. And so there is connection from this critical strip to the central zero as we have it, because it will the virtue of getting to know the position of electron, which is the real entity in this case, because the prime to their prime numbers, they are real, but in relativity to electron, don't forget that this prime, the vertical non-trivial zeros as we have them, they are prime encoded pointer to the real electron. They are the prime pointer of the electron, because we use electron to get all these vertically lined up zeros. Okay, that is that. Okay, so now let me briefly show us I want to briefly show us if do I still get it here? Do I still have it? Do I still have it? Okay, I want to okay so let me briefly show us my research publication. I want to start from the time theory, the time theory of everything. The time theory. Okay. Okay, so okay, so let me quickly show us. Okay, so good. So now this is my research publication. I'll put links to my research publications in the description section below. You can actually go through my research publication. You can see it was published on the International Journal of Scientific and Engineering Research, Volume 12, Issue 10, October 2021. So now, yes, you can see the time theory of the universe. So now, here you can get to see how formula of everything is derived. Look at it. It starts from here. It starts from here. Now, I say the space of time interval is the necessitating factor for movement, rotation, gravitation, speed, action, growth, balance, hosting of moving entity, emanation of existence, vibration, wave radiation, and so on. Then it is safe to say time is the movement of energy, electromagnetic force, strong nuclear and weak nuclear force. And energy is the movement of gravitation, which is the movement of mass concentrated matter, gravitational force. Mathematically, we can say T is the function of E, which is energy, where E is the gravitational function of mass, M. So T equal to function of gravitational function of mass and okay, so you can see that. And this is the reason we could have mass accumulation or mass convergence in that region of time trajectory. And so now, the mass of heavenly bodies implement gravitational force at mass level, but it is a worth of energy at either speed close to the speed of light or the speed of light. Therefore, we will use the speed of gravitation instead of weight of mass in E equals mc squared to arrive at the speed of the universe, and as well to quantize mass by speed of gravitation that is common to all heavenly bodies. Okay, so now having the first paragraph situation, we need to use chain rule of differential calculus invented by Sir Isaac Newton to implement the moving algorithm of time in relativity to matter, because the speed of time is not fixed but relative rather. In that case, speed of time could be termed as electromagnetic speed of relativity scaling. Can you see how I define time right there? Time is electromagnetic speed of relativity scaling. So by the virtue of relativity scaling, the momentum of time is far more higher than the speed of light. But then you can see from what I just explained, you can see that even at the region where there is change in momentum for us to have acceleration, the acceleration is being constrained even by equilateral triangle. But then we have that virtue of acceleration by the fact that the equilateral triangle is compacted. So you can see how that constancy of light speed is being so maintained. Is being so maintained. It's a kind of battle between, time and energy, and so the constancy is being so constrained. The constancy is being so maintained, rather, even at the region where we have curvature, because by the virtue of curvature we're going to have angular momentum, and so it means that there is this tiny, so insignificant influx of mass worth into that diagonal trajectory of time to allow for the mass accumulation. So now, what do we have here? So we have the chain rule. You can see dt dm equal to dt de times de dm. So now this is how you can see how we then start the derivation. So we start the derivation by just deriving time to energy to have 2e. We derive energy to mass to have 2m. By the chain rule, we then, multiply the two together. 2e times 2m, we have it to be 4em. So therefore, by the time we're to, implement, by the time we're to implement what we have here, m squared plus 1, where e equal m squared plus 1, by the time we're to implement that, we can just substitute we can just substitute this value for e, and then we do that right here, and having this, we then have it to be 4m squared plus 4m. Now the 4m squared represents the strong conveying force. I call it strong conveying force. And then the other one, 4m, represents weak conveying force. Those are now right here we only have the 4m squared to be the strong conveying force placeholder, while the 4m is the weak conveying force placeholder. So now this is how I'm able to actually match the strong nuclear force with the weak nuclear force and all that. So I have a video where I was able to explain all this thoroughly. So now to induct E equals mc squared as E in our 4em of 4m squared plus 1 close bracket m placeholder, let te. So that is how I'm able to do that. So now I say, so m equal the gravitational speed, you understand, and c equal the speed of light, you understand, and then the speed of sun's gravitational force and the speed of light respectively. Yes, I use the speed of sun's because the gravitational force of sun makes all the heavenly bodies to orbit or to revolve around sun, and that is why we need to use that. So gravitational force, and so I use that. So we use the speed of sun's gravitation because its weight force makes other planets orbit around it, you understand. So now we now have this dt dm 4em, then we put mc squared right there, then I substitute those values, and so finally we arrive at the constant speed of the universe as we have it here. And then finally we now have our formula of everything to be dt dm equal to capital Um plus 4m. So that is the derivation. So get this book, get my research publication for you to know more about this. So you can see that. You can see that. So that's it. Let me show you the second. Okay, so I want to show you the let me show you the second. Okay, so now this is the second research publication. So published on the same journal, International Journal of Scientific and Engineering Research, volume 13, issue 6 June 2022. This was published 2022. So now, seeing the anatomy of quantum gravity through formula of everything. So here you can see how formula of everything is applied. You can see in this case I use 86 kilogram mass. You understand? So you can as well just use what you have here to get the non-trivial zeros to decode its prime, and then and to see if it is truly at 0.5 phase. You can do it just as I did it for you to decode the prime. Okay, so now applying it, we have this suspended zero, this 344, and so 344. You understand? And this is, so here is, now see how this is how to implement manual annihilation. So you can see it clearly right here. You can see it clearly right here, more clearly. So that is how formula of everything is implemented. But then I now have to use, let's look at this. I use what is known as, I use derivation of time energy wave function. I have to derive this particular function as well, because when you look at how the formula of everything is applied, you see that if not for the fact that I was able to use the energy curvature value to track the arbitrary mass watts to know that indeed the electron is undefined right inside the nucleus until when the mass accumulation generates standing wave that gets connected to higher dimension to connect to electron of the higher dimension, which will be instantly converted to positron for that to allow for the instantiation of electron. If not for that curvature, I wouldn't have known that there is projection to higher dimension, because when you look at it, you see that the results that we get as truncated the watt to the power of minus 32 instead of minus 31, which is to say that which is to give us a kind of what is it called, Cauchy complete, as we have in Hilbert space function. Cauchy complete, when you have bigger space, right? When you have bigger space that envelope your smaller space, the Cauchy complete will truncate the projection to higher space. For you to, that is when you now say you have inner product. So the Hilbert space is just a vector space of inner product that is Cauchy complete. So what that is telling us is just to let us forget about that transition. The transition is the key thing, which is the quantum entanglement. We need to know, because the the transfer of information is instant. At that level, we only get information. We can't get event. Time is so instant to allow, time is too instant to allow for event. So we get information. So that is why you can see that the prime, the whole mystery of this prime encoded non-trivial zeros is all about information. So now, so for me to get the picture of what is happening, for me to actually capture the flipping mechanism at complex level, I have to derive this. Now you can see this, I have it to be, del times electric field. So when you have the momentum of time to energy to be inversely related as what we have here, you can just, multiply this del. So basically what we have right here, if you look at what we have here, we have Pauli, we have Pauli expression right here. We could have convergence as well when we have dot. So basically we have Pauli expression, which is, it means that the kind of mass spiral formation, the mass spiral formation will serve as repulsive force, which will be in form of Pauli expression. So now, then we have this derivation of del times t over derivation of e. We have it inversely related to this. And then we continue to do that, but then we now have to supply the constant speed of the universe, which is capital U. We have multiple of that inversely related to our Pauli expression right here. And then by the time, so we can, if I should read this, then it says the above section is time energy wave inverse interaction at second order derivative, where u squared is the constant speed of universe squared. The stretched entanglement is of two squared intervals from strong conveying force energy to mass watt and mass watt to mass of particles. To integrate vector structure in order to have the wave equation in 3 dimensions, we implement the following. So we want it to be in 3 dimensions because we are actually working with 2D, but then we have this phenomenon of higher dimension to create that complex system. And so we need to put that in the equation. So now we have this Pauli. Now this is where it becomes more complicated because we have Pauli expression here, then we have convergence right here. We have convergence. So now at the left side of the equation, we have Pauli expression. At the right side of the equation, we have convergence. It is ideal to actually model it like that because in the cosmological space, we have expansion. In the black hole, we have contraction. So we're supposed to have convergence right there. So now where capital T is, so now where capital T is some placeholder vector, we now apply as follow. So the capital T has served as the place, as a vector placeholder. We're trying to have 3D right here. So we then have our equation back. We have so now you can see that we now have we have some kind of slipping mechanism. We have convergence right here. And then we have inverse of that in we have inverse of that, which is being scaled at constant speed of the universe. So we have second derivation of time to energy in that sense. So basically, with this, you can get to see that even in the expansion, there is this contraction. At the quantum level, we have contraction, even though the contraction of the quantum level is divergent to the action of time trajectory to allow for the classical expansion. And it is because of that contraction of the quantum mechanics that we could have this discontinuous momentum of discontinuous momentum of that momentum at quantum level, which would support the mass accumulation at classical level. So now we can, for us to integrate relativistic mass worth, we need to equate everything to zero. So now we have the del energy vector, the inverse trajectory of time to energy momentum at the scale of constant speed of the universe. So that is equal to zero. Of course, that will be equal to zero because the inverse momentum of time to energy is more or less like ambient momentum, which can still be equal to the del squared of electric vector, because there is no mass worth. So at that point, there is no relativistic mass worth, so we have it to be symmetric. But now see what happens. We have this to be the relativistic mass worth according to special relativity as declared by Albert Einstein. Now, the moment we integrate this relativistic mass worth into the equation, we then realize that something happened. Now, because of that relativistic mass worth, then we are unable to get symmetric nature again. So now, if you look at what we have right here, the mass worth is being introduced. We have the inverse momentum of time to energy, which is second derivation. So now we need to actually model the decaying mechanism of the black hole, and that's done at Planck scale. That is why I have to put this Planck right there, the Planck size, the Planck constant. So now that we have this, you can see that what we now have is pointing to something so profound, because we have realized that now we can rearrange and easily generalize these to 3 dimensions by turning this equation into vector equation with wave and particle duality, duality behavior of wave function. So now we have made this to be by introducing this. Yes, first of all, we introduce the wave function, to model, for us to be able to see clearly what is happening with the wave function. We have to introduce the wave function, and then we want to see the effect of this at higher dimension. We want to see it connected to higher dimension 3D and see the picture of complex system. What I'm trying to capture is to get the flipping mechanism. I want to see the flipping mechanism. When mass is involved, we have asymmetric from Big Bang singularity. We have asymmetric nature from Big Bang singularity to black hole singularity. Then I want to see what that mass worth is, how that mass worth is causing spiral formation to cause flipping mechanism. But that flipping mechanism, I know it will be done at higher dimension, which is at 3D, and so that is why we have to do it like this. Now, by having it to be this, now see what happens at the final result. At the final result, we have the wave function to the left to be at the top, where we have second derivative of wave function to the second derivative of energy. This capital E represents total energy now, not vector, minus m squared capital U squared over Planck constant squared. Then you can see that the wave function here is at the middle. So that is the static and undulating. So the wave function at the middle represents static and undulating wave, just as I have discovered using the formula of everything. So now, at the other side of the equation, see what we have. When you scale that momentum, when you scale it at the constant speed of the universe, because the constant speed of the universe in the formula of everything actually, transcend from the substrate dimension to higher dimension. Now, see what happens? Because that scale will connect the substrate dimension to higher dimension. Now we have that flipping mechanism. The wave function is at the bottom right here at the right side of the equation. So second derivation of time to second derivation of wave. So you can see what we have. We have that flipping mechanism. We have the flipping mechanism, and from that we get to know that the flipping mechanism is done at higher dimension, and it is done at the event horizon or at the present time peregrination to, cancel the expanding field of the expanding cosmological space in order for us to have the contracting field of the black hole. So that is that. Okay, so that is that, and then if you read further, you get to see, where I talk about causality and then non-causality, because in the black hole, whether you like it or not, there is nothing like causality. There is nothing like let me quickly show you something. Oh, okay, I want. Oh, no. Okay, so I want to quickly show us something. Okay, I want to briefly use this. Okay, so now we have this. So Big Bang, you can see it clearly right here. So I'm going to use this to fully explain it better. So if you look at this, is Sotadeology triangles. Now, when you have equilateral triangle, from this arithmetic summation per layers, you can see that we have constancy at one side, we have variation at other side. When you dissect this diagonally, the variations are actually contracting towards the zero. So we didn't have this one initially. If you consider this single equilateral triangle of the blue pattern, we only have 0 here at the right side, and then we have 1 here. So, but the moment we have the flipped version of this equilateral triangle in this red pattern, then we're able to have, now this blue equilateral triangle is non-existent without this red equilateral triangle, and yet this red equilateral triangle is non-existent without this higher equilateral triangle. So now we have this transition from from 2D substrate dimension to higher dimension 3D. So then we have this unified identity of dimension and also the unified identity of mass of particles to give us the instantiation of everything that we have here. So as at the point that electron wasn't instantiated, even though we could have the mass, even though we could have the classical mass fundamentally present, fundamentally available, because it is being relativistically connected to classical arbitrary suspension, yet it has no meaning, because without consciousness, the mass worth, the classical mass worth, is nothing. So now the virtue of consciousness happens almost instantly. The classical mass worth will cause consciousness to happen as if it is fundamental, but at quantum level, consciousness is emergent. Consciousness is emergent because consciousness will happen at the point where we have quantum entanglement. The instant transmission of that information of positron to electron will be the feedback that will be sent, instantly sent to the classical mass world. So at that level, information is operational. Event is not operational. So now, so even though we could have the classical mass world fundamentally all the time, that mass world will only fulfill its destiny being conscious, by being conscious of its environment. And we have that from quantum, from complex level, through quantum mechanics to classical level. So now you can get to see that the whole system is so complex. And if you now look at how entanglement is done here, you see that the moment we have this red arithmetic summation pattern, the moment we have this inversely related red pattern, we then have addition of 1 to the 0 at right, where we have 55. But that 1 cannot go through the 0. It will be displaced. So if the 1 is being displayed inward, then the 0, the what is it called? If the 1 is being displayed inward, then the 1 here too will be displayed inward. So basically you can see that the 1 here is displaced inwards, and then the 1 here too must be displaced inward, and that is entanglement for you. Whatever that happens to one particle at its side must as well happen to other particle. And so you can see that what we have here is not the same. We have 0, 1, which is 1, and here we have 1, 0, which is 10. And that is to tell you that from Big Bang singularity to black hole singularity, we must have this asymmetric nature for momentum to continuously be exercised. And so you can see that only at this vertical trajectory that we could have instantiation of 1, which is the totality of emergence or totality of instantiation, and then we have 1 right here. Now this one, the 1 up here will not be defined until we have this one, and this one here will not be defined until we have the one at higher dimension. So that is the picture, that is the whole picture. So now if you look at the 5, when we decoded the non-trivial zeros, we have it to be 5, which is, prime number. Now at the base of this equilateral triangle, what do we have? We have the 5. The 5 is at the center. So now the 5, as we have it, is at the 0.5. Is at 0.5 being suspended to, because it happens to be half pointer. It happens to be, yes, half pointer to, it happens to be, oh, sorry, I'm actually referring to the 5 of the ninth position. The baseline, what we have at the center of the baseline is plus, and so the inversely related pattern to as plus. Plus plus plus, like signal will give us repulsion. You understand? Will give us repulsion, and that is the kind of energy that we have at the center that will serve as resistance to the free fall. You understand? And so basically we can get to see that the 5 is suspended at the base, just as we have for the non-trivial zeros. And so the whole thing is that when you count the numbers that you have to 1 from the 5, and you count you count from the 5 the numbers that you have to the 1, it will also be, less than 1, 2, 3, 4 before you reach 5. And when you count this 1, 2, 3, 4, 1, 2, 3, 4. Okay, so now you can see what did I get wrong here? So now the asymmetric nature, don't forget we were able to identify the asymmetric nature of that x-axis to prove that infinity as we have it. So basically from these Sotadeology triangles we can get reality of any object before any object can be instantiated in the space. In space, we should have all these features. The equilateral triangle is not entirely symmetric. We have this embedded asymmetric nature for it to actually, converge mass worth around the edges of that shape, for that shape to be instantiated. So basically that's all. And then when we dissect this further, you can see that we have, the toggling of odds number, of odds to evens, and that is an indication of continuous momentum. So there is this kind of transition from layer to layer right inside the equilateral triangle. And so basically we have seen that prime number 2 is related to even number, because the trivial zeros of the even numbers we have to support to instantiate the reality of the prime number as have worth of the entire whole that must be realized. Okay, so that is that. With this, I believe I've been able to convince you and not to confuse you that Riemann hypothesis is being solved. So that is that. That is the video, and I'm going to put it in my YouTube channel. It will be available for all people all over the world to see. And so Clay Millennium should get me my money. That is the solution to Riemann hypothesis. That is the solution. Thank you. God bless you. So I'll call it a day here. I remain my humble self, Sotadeology.